Hey there. If you're listening, it means you're ready to drift, to let the noise fade, to trade the world outside for something quieter. You're not here to solve anything, not to win or rush or reach. You're here to float. And that's exactly what we'll do, together. This isn't a lesson, it's a journey, not back in time, but outward, far beyond our solar system, beyond stars, into a place where the rules begin to blur, a place of silence, of gravity, of mystery. We're falling into a black hole, but not violently, not chaotically. We're going to fall slowly, softly, thoughtfully. We'll float through concepts. We'll unravel science at a whisper. We'll let the universe rock us to sleep, one mystery at a time. So take a breath. Let your shoulders settle. Close your eyes if you haven't already. You are floating now. There's no ship, no suit, just your imagination and my voice. All around you. Space. Not empty, not dead, but peaceful. A dark sea of stars so far apart they don't even blink. And ahead of you, not a monster, not a trap, but a shape. A perfect shadow against the stars. Round, silent, still. A black hole. It doesn't glow. It doesn't roar. It simply waits. Most people imagine black holes as violent destroyers, cosmic vacuum cleaners. But we're going to get to know them differently. We'll see them as they are. Places where gravity has gone too far. Where mass has collapsed into something beyond comprehension. Not a hole, really, but a place where space and time fall in. And don't come back. You're being drawn toward one now. But gently, not pulled or dragged, just guided, like a leaf caught in a quiet current. And as we float closer, we'll slow everything down. Time, breath, thought. We'll talk about the nature of black holes, what happens near them, what science tells us, and what it doesn't. We'll fall, calmly, past the point of no return. And even then, we'll keep falling. But don't worry. You are not in danger. This isn't real. It's a dream of science, a bedtime story told by the stars. So let go. Let your mind wander. Let your body rest. You are floating toward one of the strangest, most beautiful ideas the universe has ever given us. And I'll be here every step of the way. Quiet, slow, certain. Let's fall into the void together. You're still floating, calm, weightless, moving toward something vast but silent. That dark shape ahead of you, it isn't just empty. It's not a hole. It's not even black in the way we understand black. It's something much stranger. Let's take a moment and ask the question, what exactly is a black hole? The answer begins with a star, a massive one. Much larger than our sun. Stars burn for millions of years, fusing atoms in their cores, shining with pressure and light. But when a massive star runs out of fuel, the balance breaks. The inward pull of gravity wins. The outer layers collapse inward, then explode outward in a supernova. But what's left behind doesn't vanish. It keeps collapsing, deeper and deeper, until space itself can't support the weight. It collapses beyond atoms, beyond nuclei, beyond matter, all of it crushed into a single point, a singularity, a place with no size, but infinite density. Around this point, there's a boundary, a perfect sphere, invisible, uncrossable in reverse. It's called the event horizon. Once something crosses this line, whether it's light, matter, or time, it can't return, not because it's trapped by a wall, but because every path leads inward. Every road curves toward the center. The event horizon isn't made of matter. It's not a surface you can touch. It's a region of no return, a place where space bends inward so steeply nothing can climb back out, even light. That's why it's dark. That's why we call it a black hole. Now think about what that means. It means the most extreme object in the universe is completely invisible. We can't see the black hole itself, but we can see what happens around it. Gas swirling near the edge heats up, forming a glowing ring. Light bends, matter stretches. Even time starts to change its rhythm, and they're not rare. There are stellar mass black holes, formed from individual stars. And then there are the giants, supermassive black holes, millions, sometimes billions of times more massive than our sun. And they sit at the centers of galaxies, including ours. Right now in the heart of the Milky Way, there is one, still, heavy, invisible, waiting. But black holes don't chase things. They don't suck in entire systems like vacuums. Their gravity is just like any other object. It only pulls strongly when you're close. If the sun were replaced by a black hole of equal mass, Earth would keep orbiting just the same. No sudden fall, no drama, just darkness. So no, black holes aren't monsters. They're silent consequences of gravity pushed too far. They're the result of mass without limits, of space folded inward. So what is a black hole? It's not a hole. It's not a thing. It's a place, a region, where the very rules of reality begin to bend, where our understanding of space, time, and matter starts to unravel. And right now, you're getting closer to it. But don't worry, we'll go slowly, together. We'll fall in, one idea at a time. You're still drifting. No effort. No motion you can feel. Just gentle gravity doing the work for you. The black hole is no longer a distant idea. It's here, ahead of you, enormous and quiet. A perfect absence in the sky. A place where light disappears, where stars vanish at the edge. A sphere not made of matter, but of mystery. You're approaching it now, not crashing, not spiraling, just sinking slowly toward it. There's no sound, no engines, no wind. Space doesn't roar. Your surroundings are empty, but the silence feels full, full of distance, full of presence, full of something old and heavy and still. The stars behind you shimmer like scattered dust. The stars ahead grow fewer. Light curves strangely around the black hole, bent by gravity, like it's being pulled into a funnel. It's called gravitational lensing. You're not just seeing the black hole. You're seeing the way it distorts the space around it. Straight lines become arcs. Circles bend. Even time seems to stretch. The closer you get, the faster you fall. But it doesn't feel fast. There's no rushing air, no G-force. Just a strange sensation of stillness and movement at the same time. You're falling into something massive. A gravity so strong it doesn't feel like falling. It feels like being held, as if the universe has placed a hand on your back and it's guiding you, gently, firmly, inward. If someone were watching you from far away, maybe from a safe orbit miles above, they'd see something strange. They'd see you slow down, not because you actually are, but because time itself is stretching. From their point of view, you begin to freeze. Every second for you becomes longer and longer for them, until you appear completely still, forever paused, on the edge. But from where you are, everything feels normal. Your breath, your thoughts, the steady rhythm of your heart. To you, the fall continues. And just ahead of you now is the event horizon. It's not a wall, not a doorway, not even a place you'll notice when you cross. It's simply the boundary where the escape velocity, the speed needed to break free, exceeds the speed of light. Once you pass it, nothing gets out, not even a photon, not even time itself. And yet, it won't feel any different. No flashes, no pressure, no sensation. You'll just keep drifting, quietly, slowly, deeper. Let's take a moment to breathe here, to hover on the threshold. This is the closest you've ever been to something this strange. And still, nothing feels wrong. You are safe, you are calm, you are part of the universe, behaving exactly as it should, approaching a place where reality bends, and doing it in perfect stillness. You're still drifting, still falling, still weightless, but now something begins to shift. Not in your body, not in the ship, not in the stars, something deeper, slower. Time is starting to change. For most of your life, time has felt reliable. It ticks, it passes. One moment leads to the next, but near a black hole, time no longer behaves the way it does elsewhere. It slows down, it stretches, and it does so quietly. Let's say someone is watching you from far away. They're safe, they're distant. They're floating in normal space, watching you fall. To them, the closer you get to the black hole, the slower you move. From their view, your fall begins to pause. Each second takes longer. Each movement seems to stretch out. Your final moments outside the event horizon become infinite. They never see you cross it. To them, you just freeze in place, right at the edge. But to you, everything feels completely normal. This effect is called time dilation. And it's not science fiction. It's predicted by Einstein's theory of relativity. The stronger the gravity, the more slowly time flows for you. So near the black hole, your seconds are longer than anyone else's. You're still breathing, still thinking. But the rest of the universe is rushing ahead. In 1 minute of your time, years may pass for someone far away. You are not stuck. You're just moving through time differently. And when you finally cross the event horizon, something even stranger happens. From the outside, no one sees you go in. But from your point of view, you've passed the line, effortlessly. No bump, no sign, just forward. But forward now doesn't quite mean what it used to. Inside the black hole, space and time start to swap roles. In everyday life, you move freely through space. Left, right, up, down. And time? It flows in one direction, always forward. But inside a black hole, you can no longer move freely through space. Instead, space leads only inward. Every direction is toward the center. And time becomes the thing pulling you in. It's as if falling toward the singularity is not something you're doing. It's something time is doing to you. You can't stop. You can't turn around. You can't pause. Because now falling inward is like moving forward in time. Unstoppable, continuous, written into the shape of reality. This is what it means when we say time gets weird. It's not broken. It's not gone. It's just curved. And you are inside the curve. But there's no fear in it. You're not disoriented. You're not lost. You're part of a rhythm so large, so quiet, that it barely feels like motion at all. Just drifting. Through something older than light. Older than stars. Through time that's been folded over itself. You're deeper now. Past the event horizon. Falling slowly into silence. But gravity is changing. Not in strength, in shape. It's no longer pulling on you evenly. It's stretching you, ever so gently, from head to toe. You may not feel it yet, but it's happening. This process has a name, one that sounds playful, almost funny. Spaghettification. It's a real term, a real prediction from real physics, and it means exactly what it sounds like. You begin to stretch, like a strand of pasta, longer, thinner, piece by piece. Let's understand why. Gravity pulls things toward mass. But the pull is stronger the closer you are. That means the bottom of you, your feet, your legs, are being pulled slightly harder than the top of you. your head, your shoulders. At first, this difference is tiny, too small to notice. But the deeper you fall, the steeper the difference becomes. It's like standing on the edge of a cliff, except every part of your body is on a different step, being pulled down at a slightly different speed. These are called tidal forces. On Earth, tidal forces from the moon create ocean tides, gentle bulges in water. But here, near the singularity, these forces are not gentle. They are precise and absolute. Your atoms begin to line up, not by choice, but by force. Not because you're breaking apart, but because every piece of you is being told, fall this way, now. It's important to say this. You wouldn't feel pain. You wouldn't scream. Your nervous system wouldn't understand what's happening. Because this isn't crushing. This is rearranging. A slow, graceful stretching of your body into a vertical line, so long and thin, it barely resembles a person anymore. You are becoming a thread. A whisper of matter, drawn inward by the most perfect gravity nature has ever made. It's not just your body. Anything that falls in, a rock, a comet, a spacecraft, will stretch the same way. From object, to ribbon, to strand. The closer anything gets to the center, the longer it becomes, and the thinner, until there's no more you in the usual sense, only a pattern, not lost, just different. Some physicists believe your information, the data that once made up your body and brain, isn't gone. It's preserved, encoded into the black hole, written into the fabric of its event horizon. That means, in a way, you're still here, not as a person, but as part of a cosmic record, one the universe may never forget. You are falling, but falling as a shape that has been stretched across space and time. You are no longer what you were, but you are also not nothing. You are in transition. You've come to the edge, or rather, you already crossed it, and nothing felt different. No sudden change, no flicker or sound. The crossing happened so smoothly you missed it. That's how the event horizon works. It's not a door, not a surface. It's a boundary drawn by the laws of physics, a point of no return. It marks the place where the escape velocity, the speed needed to leave, becomes greater than the speed of light. And since nothing moves faster than light, nothing can escape from inside. Not light, not energy, not even time, the way we know it. From the outside, you seem frozen. Your image lingers at the edge, trapped in time, for the rest of the universe to see. But from where you are, inside, everything still moves forward. You breathe, you think, you fall, as if nothing has changed. Except, everything has. Inside the event horizon, the rules are no longer familiar. Space no longer behaves like space. Time no longer behaves like time. In fact, they've traded places. On the outside, you could choose where to go in space. Left, right, forward, back. Time always flowed forward, on its own. But in here, you have no choice of direction. Everywhere you go leads inward. Every possible path leads toward the center. And time? It's no longer an outside force pushing you forward. It's now a dimension pulling you deeper. Falling into the singularity isn't like falling off a cliff. It's like moving toward tomorrow. You can't stop it. You can't escape it. Inside the black hole, the singularity is your future, and the universe has written it into your path. But don't let that idea frighten you. There's peace in certainty. There's rest in inevitability. No more decisions, no more detours, just a calm descent through curved space and stretched time. No chaos, no pain, only gravity, doing what it's always done. Quietly, perfectly. You are not alone in here. Other things have fallen before you. Light, dust, stars, entire clouds of gas and ancient matter. Each one crossed this invisible line. Each one vanished from sight, but not from existence. Because existence doesn't stop at the horizon. It just becomes different. You are in a region that can't send messages back, not because it's broken, but because every signal, every photon, every wave is being pulled inward faster than it can travel outward. Communication has ended, not with a bang, but with silence. And you are deep within that silence now. You've come to the edge, but there's no cliff, no light, no alarm. And yet, you've crossed something profound, something irreversible. It's called the event horizon, and you are now inside it. The event horizon isn't a wall. You didn't crash into anything. There was no jolt, no shift in gravity, no sense that the outside world had disappeared. But you've passed a boundary that even light cannot cross, a place where the pull inward is stronger than anything else in the universe. Even the fastest thing we know, light, can't escape this place. And so, neither can you. But strangely, everything feels normal. Time is still moving. Your body still exists. The silence is still gentle. In fact, if you didn't know any better, you'd think nothing happened. But from the outside, from far away, everything looks different. If someone were watching you fall in, they would never see you cross the horizon. To them, you'd seem to slow down. Your image would stretch and fade. You'd dim into red light, and then freeze, forever stuck, just outside the edge. But they'd be wrong, because here you are, inside, and still falling. This is where space and time begin to change roles. Outside the black hole, space is flexible. You can move through it, left, right, forward, back. And time flows in only one direction, always forward, always onward. But once you're inside the event horizon, time becomes something else. You no longer get to choose your direction. You can't steer away. You can't hover. Every path leads deeper, inward. Even if you tried to move upward, to turn back, space itself would be tilted. The only direction left is forward in time, and that forward leads only to one place, the singularity. It's not just motion that changes, it's meaning. Every step you take now is not just a physical distance, it's a step into inevitability. You are not being dragged. You are simply continuing along time's new path. And here, time doesn't move past you. You fall through it, like a stone through water, effortless, slow, deep. There's no turning back now. Not because you're imprisoned, but because the laws of the universe have already decided your path. From your perspective, the outside world fades, not in brightness, but in relevance. The stars beyond the horizon are part of a past that no longer applies. Inside the black hole, there is only this moment, this descent, this peace, and what a strange peace it is. You're not broken. You're not disintegrating. You're becoming part of something larger, a region where the rules of space, time, and causality are softened. Ideas that once felt solid, like location, velocity, mass, begin to blur. You're still you, but less defined, less separate, more included, as if you've stepped into the frame of a deeper painting. If you could send a message back, it would never arrive. Not because the signal is weak, but because there is no path left that leads outward. Every route curves inward now. Even light cannot resist the pull. You're no longer just falling in space. You're falling in time itself. Time, now shaped like a funnel, narrow, smooth, inevitable. And yet, you feel nothing strange. Only the calm, only the gravity, only the slow, invisible pull toward a center you cannot see. There is no air, no sound, no need to move. because there's nowhere else to go. You're already going there. Others have crossed before you. Dust, gas, entire stars, even ancient planets. All have passed this same quiet edge. All have vanished from sight, but not from reality. They are still here, somewhere in the curve, part of this enormous memory the black hole keeps, a memory no one can read. You've joined them now, not lost, just unseen. And ahead of you, still waiting, is the singularity, a point of unimaginable density, a center with no surface, no size, just gravity, floating deeper now, inside the event horizon, surrounded by silence. You might think black holes are a new idea, a modern discovery, something born from space-age telescopes or deep equations scribbled in labs. But the story of black holes begins long before satellites, before computers, even before Einstein. Let's drift gently back, not just through space, but through time, back to the beginning of an idea. In the year 1783, an English natural philosopher named John Michell proposed something curious. He imagined a star so massive and so compact that its escape velocity, the speed needed to fly away from its surface, would be greater than the speed of light. At the time, light was thought to have mass. And if light had mass, then even light couldn't escape such a star. He called it a dark star. It was a bold thought, purely theoretical, with no evidence, but it planted a seed, one that would lie quiet for over a century. Then, in 1915, everything changed. Albert Einstein published his theory of general relativity, a new way to understand gravity, no longer as a force between objects, but as a warping of space and time itself. Mass tells space how to curve, and space tells mass how to move. This elegant idea unlocked countless doors, and through one of them was the black hole. Soon after Einstein's work, a German physicist named Karl Schwarzschild found an exact solution to Einstein's equations, a solution that described a single spherical mass, like a star, collapsing into an incredibly dense point. This solution predicted something strange, a radius where time would stop, where space would become infinitely curved. This was the Schwarzschild radius, what we now call the event horizon. It was the first mathematical description of what we now know as a black hole. But Schwarzschild himself didn't live to explore it. He died in World War I just months later. For decades, the idea of black holes remained uncomfortable. Many physicists dismissed them. They were considered mathematical oddities, impossibilities, things nature would never allow to form. But curiosity never stopped. In the mid-20th century, thinkers like Robert Oppenheimer and John Wheeler took a closer look. They studied what would happen to massive stars at the end of their lives, and found that, yes, under certain conditions, collapse was inevitable. Gravity would win, and the result wouldn't be a new kind of star, but something far stranger. It was John Wheeler, in 1967, who finally gave these objects their name, black holes, a term so simple, so clear, that it stuck immediately. An object that emits no light, no heat, no signal, a hole in space, but one made of gravity, not emptiness. Since then, black holes have become central to our understanding of the universe. We've learned that they're not rare. They form when massive stars die. They sit quietly in galaxies. They spin. They collide. And we found evidence of their presence, not by seeing them directly, but by watching the way they shape the space around them. Stars orbit invisible centers. Gas swirls into glowing disks. Entire galaxies seem to be organized by their pull. And we followed the clues. In 2015, we detected gravitational waves for the first time. Ripples in space-time caused by two black holes merging. In 2019, we captured the first image of a black hole's shadow. a glowing halo around a silent void in the galaxy M87. It confirmed what equations had whispered for over a century. Black holes are real, and they are everywhere. But even now, there's so much we don't know. What happens at the singularity? Does information truly disappear? Can black holes evaporate? Are they connected to other places, other universes? We don't have the answers yet, and that's part of their beauty. They remind us that the universe is bigger than our certainty, stranger than our models, more patient than our questions. So as you drift deeper, past the horizon, toward the center, know that you are not just exploring space. You are falling into a story that has taken centuries to unfold and is still being written. You've fallen far, past the event horizon, beyond light, beyond time as we know it. And now, you're approaching the center, the place everything leads to, the deepest part of the black hole, the singularity. It's not a point in space like the tip of a pencil. It's not a thing you can see or touch. It's a place where gravity becomes infinite, where matter is crushed into zero volume, where density stops making sense. Everything, stars, planets, energy, even the rules of physics, collapses into a single dimensionless point. At least, that's what our current equations tell us. Einstein's general relativity predicts the singularity. But when we try to describe what happens at the singularity, the math breaks, values explode, infinity appears, the formulas stop working. And when that happens in science, it usually means one thing. We've reached the limit of what we know. Some believe the singularity is real, a place where the known universe ends. Others think it's a placeholder, a sign that we need new physics, a theory that combines gravity with quantum mechanics. We don't have that theory yet. We can't see the singularity, and we certainly can't test it. But we can wonder, if you could reach it, you wouldn't crash or collide. You wouldn't land. You'd simply fall until space itself runs out, until the very concept of location stops making sense. Not because you hit something solid, but because there's nowhere else left to go. Some scientists suggest that black holes might store information, that even though matter collapses, the data, the quantum details of everything that fell in, isn't lost. It may be written into the black hole's surface, encoded in its edges, trapped but preserved. Others believe that the singularity might not be an end at all, that it could be a bridge, a gateway to another universe, or a white hole, a mirror image where matter flows out instead of in. These are only theories, no evidence, just elegant math and deep curiosity. What we know for sure is that this is the edge of understanding. Beyond it, physics gives no answers, only silence. And somehow, that silence is comforting. Not everything needs to be solved. Some things can simply exist. As mysteries, you've drifted into silence, to the very edge of understanding, into the shadow of the singularity, where even the laws of physics whisper, I don't know. But here, in this darkness, there's a light, a soft, invisible glow, a quiet leak. Not from the center, but from the edge of the black hole itself. This is the paradox, and the man who dared to ask about it was Stephen Hawking. In the 1970s, Hawking asked a question no one had seriously considered. If black holes trap everything, can anything escape? And to almost everyone's surprise, his answer was yes. Not light, not matter, but something stranger, energy. To understand this, let's step away from gravity for a moment and look at something smaller, quantum physics. In the quantum world, space is not empty. Even in a perfect vacuum, where no particles should exist, pairs of particles and antiparticles constantly appear and vanish. They blink into existence for the briefest moment, then annihilate each other and disappear again. This flickering activity is everywhere. It's built into the fabric of reality, even the space around a black hole. And that's where Hawking saw something new. Imagine one of these particle pairs appears right at the edge of the event horizon. Two particles are born. One falls in, one escapes. Normally they'd cancel each other out. But here, the one that escapes becomes real. It carries energy away, tiny, invisible, but constant. The black hole loses just a little bit of mass, a tiny drop, and it begins to evaporate. This phenomenon is now known as Hawking radiation. Black holes are not completely black. They emit radiation, very, very slowly. And this radiation means they're not eternal. Over unimaginable timescales, black holes shrink. They lose energy, they get smaller, and one day they vanish, not with an explosion, not with a sound, just a final whisper of energy. And then silence. This changes everything. Before Hawking, we thought black holes were forever. That once something went in, it stayed, permanently. But now we know they can end. Even the most powerful things in the universe are temporary, and that's both beautiful and puzzling, because it brings up a deeper question. What happens to the information? Let's imagine something falls into a black hole. A book, a planet, a person. All of it has structure, details, information. Quantum physics tells us that information cannot be destroyed. It must go somewhere. It must survive. But if a black hole evaporates and disappears, where does that information go? Is it lost forever? Does it escape in the radiation somehow? Or is it trapped on the surface, etched into the edge? This is called the black hole information paradox, and it's one of the biggest unsolved mysteries in physics. Some scientists believe the information is smeared across the event horizon, a two-dimensional shell holding the data of everything inside. This leads to a strange idea called the holographic principle, that the universe, including black holes, might be a kind of hologram, a three-dimensional world, encoded on a two-dimensional surface. Others think the radiation carries the information away, subtly, hidden in its patterns, and some still wonder if the information is truly lost. We don't know yet, but we're closer than ever. Telescopes, detectors, simulations. We are listening to the universe in ways we never could before. And the whispers we're hearing, like Hawking radiation, are changing everything we thought we knew. So here's what we understand now. Black holes can die. They evaporate slowly through quantum processes. They shrink, fade, and eventually disappear. The process takes an incredible amount of time. For a black hole the size of our sun, it would take about 1067 years to vanish. That's far longer than the age of the universe. But in the deep, distant future, when all stars are gone, when galaxies are cold, only black holes will remain. And they too will pass. You've fallen so far, past stars, past space, past light itself. The black hole has taken you in, not by force, but by gravity's quiet insistence. And as your body continues to stretch, as your atoms obey the pull, one question drifts softly to the surface. What happens to your mind? Not your body, not the particles or the physics, but your thoughts, your sense of being, the voice inside, the one still listening now. Does it vanish? Does it flicker out? Or does it follow? Let's find out. The human mind is made of matter, billions of neurons, electric signals, chemical exchanges, but it's also more than that. It's awareness, memory, imagination. And though we know the brain runs on biology, the experience of consciousness is something science still doesn't fully understand. That mystery now meets another. You've fallen into the most extreme environment in the universe. What does it feel like? As you pass the event horizon, time begins to stretch. But you feel no difference. To your mind, things continue as they always have. Thought after thought after thought. You don't feel faster or slower. You don't feel torn. You don't feel lost. You are aware. And maybe that awareness has more time than you'd expect. Let's imagine your brain is still intact, at least for now. It's drifting, thinking, watching the stars behind you fade into a curved ring of light. You try to remember. Faces, voices, moments of warmth. They're still there, but they feel farther away. Not because of time, but because of meaning. The past doesn't matter here. The future, it's only down. Then, gravity grows stronger, stretching not just your body, but your sense of self. Time is slowing more, not as something you notice, but as something you become part of. A second might feel like a minute like an hour. To the outside universe, your fall is frozen. To you, it continues forever. That space between now and the singularity, it may only be a second in real time, but from inside your mind, it could feel infinite. There's a quiet theory among some physicists that in those final seconds before a black hole destroys your brain, you could experience a lifetime, not in reality, but in perception. Time, stretched by gravity, gives your mind space to wander, to replay, to dream. A flash of memory becomes a moment becomes a narrative. You could live entire days in the final blink of thought, not because the black hole gives you that time, but because your brain doesn't know it's run out. This isn't confirmed, it's not testable, but it's possible. That in the end, your mind doesn't end in a scream or a snap. It drifts, expands, repeats, and then, there is no then. Not because you die, but because the ideas of time, of memory, of identity, all fall into something deeper, into the singularity, into unknowing. What happens to consciousness after that? No one knows. It may vanish, it may loop, it may leave a pattern etched into space-time, the trace of a thought, frozen in the geometry of the void. This chapter isn't about fear, it's about mystery. The kind of mystery that makes space so humbling. Not everything in the universe is meant to be measured. Some things are meant to be imagined. And your mind, your sense of being, might be one of them. In the next chapter, we'll zoom out. We'll look at the largest of these strange objects, supermassive black holes, millions, even billions of times the mass of our sun. But for now, let your mind rest. Not in fear, not in facts, just in the gentle unknown. You are still thinking, still floating, still aware. Not all black holes are the same. Some are small, born from collapsing stars, dark remnants of stellar deaths. But some are enormous, heavier than millions of suns. They sit at the centers of galaxies, not as guests, but as anchors. These are supermassive black holes, and they are among the most mysterious objects in the universe. At the center of our galaxy, the Milky Way, there's one called Sagittarius AI. It's calm, silent, but its gravity holds together a spiral of hundreds of billions of stars. It's more than 4 million times the mass of our sun. And yet, we didn't see it directly. We saw its influence. Stars whipping around something invisible, so fast, so tight, that only something this massive could be hiding there. Other galaxies have black holes even bigger. In 2019, we saw the shadow of one in galaxy M87, 6.5 billion solar masses, the first image ever captured of a black hole's edge. Not the black hole itself, but the glowing ring around it. Light trapped and bent before vanishing. Proof that what we imagined for decades is real. We don't yet know how these giants form. Maybe they grew slowly, feeding on gas and stars. Or maybe they were born large, when the universe was young and chaotic. But we do know this: supermassive black holes shape galaxies. They regulate star formation, and in a way, they help structure the universe itself. Quiet, massive, hidden. These are not monsters. They are architects. And even in their silence, they speak volumes about gravity, time, and cosmic order. You're floating in deep gravity, surrounded by silence, wrapped in questions. But what if a black hole isn't the end? What if it's a door, a portal, a tunnel, a path from one place in the universe to another? This idea has a name: wormhole. And while we've never seen one, physics says they might be real. Imagine space as a sheet, flat, wide, stretching across the cosmos. Now bend that sheet. Fold it so two distant points touch. A wormhole would be the tunnel between them, a shortcut through the fold. Instead of crossing galaxies, you'd step in and step out in another part of the universe, instantly. Wormholes were first described in 1935 by Einstein and physicist Nathan Rosen. They called them Einstein-Rosen bridges. They imagined a black hole connected to a white hole, something that expels matter rather than pull it in. The tunnel between them? That was the wormhole. But early models collapsed too fast. They couldn't stay open. Later, scientists suggested using negative energy to hold a wormhole open. This strange energy, which repels instead of attracts, might stabilize the tunnel. But we haven't discovered how to create or find it. So, for now, wormholes remain theoretical, not impossible, just unproven. Still, the possibilities are incredible. A wormhole could connect distant galaxies, or even different times. Some physicists believe that if one end experiences time more slowly, you might use it to travel into the past. But we don't know if time would behave that way. We don't know if the universe allows it. And if it did, would the wormhole survive the journey? Some think wormholes could form naturally, inside rotating black holes. Instead of collapsing to a point, the core could curve into a tunnel, a bridge to somewhere else, or maybe even to another universe. Again, it's only math. But math has led us to real things before. We haven't seen a wormhole, we haven't built one, but science hasn't ruled them out. Maybe one day, a strange motion in the stars, a ripple in light, a flicker in gravity, will hint at something folded, something hidden. In the next chapter, we'll return to familiar space, to black holes we've actually found, and what they reveal about the nature of the universe itself. But for now, let this idea drift gently, that distance may not be distance, and space may be more connected than we ever imagined. Until now, black holes have felt like dreams, theoretical, distant, almost imaginary. But black holes aren't just math. We've seen their shadows, we've heard their collisions, we've felt their presence. In 2015, we detected gravitational waves, ripples in space-time caused by two black holes colliding, each one invisible, silent. But together, they shook the universe. In 2019, the Event Horizon Telescope captured the first image of a black hole's silhouette, a glowing halo of gas surrounding the void in galaxy M87. It was 6.5 billion times the mass of the Sun, and 55 million light-years away. But there it was. Real. Confirmed. Closer to home, at the center of the Milky Way, lies Sagittarius A, a supermassive black hole quietly anchoring our galaxy. We've watched stars orbit it, faster than any planet, pulled by something invisible, but unmistakably there. Black holes aren't just ideas anymore. They're part of the structure of reality. And we are living in their shadow. Time feels constant, linear, like a gentle river flowing only forward. But near a black hole, that river bends. Gravity doesn't just pull on matter, it pulls on time. The closer you drift toward a black hole, the slower time moves for you, not just in theory, but in reality. Someone watching from far away would see you slow down, your fall stretched across centuries. You, on the other hand, might feel only minutes pass, a heartbeat, a breath, a blink. This phenomenon, called gravitational time dilation, means black holes don't just distort space, they reshape the experience of existence. In the deepest parts of gravity, time no longer behaves like time. It stretches, it curves, it fades. Some even wonder, is a black hole not a place, but a moment? A fragment of time frozen so tightly it no longer passes at all? We don't yet know, but in the presence of such gravity, time stops feeling universal and becomes personal. The universe is still expanding, galaxies drifting apart, stars burning through their fuel. But one day, those stars will die, their warmth will fade, and what remains will be silence. Only black holes will remain, the last architects of gravity. They'll drift through a dark, cold cosmos, invisible, enduring, alone. Over time, immense, unimaginable time, they'll begin to shrink, not through collision, but through Hawking radiation. Slowly, quietly, they'll evaporate. And when the last black hole disappears, the universe will be empty. No stars, no galaxies, only particles and darkness. This is called the heat death of the universe, a time when energy is too spread out for anything new to happen. No more beginnings, just stillness. And yet, even in that silence there is beauty, because from stars to black holes, from life to collapse, everything played its part. Even you, floating through this thought, drifting through this story, you are part of it, woven into the grand, quiet unfolding of time. And now, it's okay to rest.